Before we're going to start talking about our amazing project, I want you to imagine that you went to the doctor today and that the doctor is telling you, listen, I have an amazing model and I can predict whether in 5 years you'll have a stroke. And you're going to be like, wow, that's amazing. I want to know what's my results. And the doctor is telling you, okay, based on your information, in 5 years, there's a chance of 95% that you'll have a stroke. And, after freaking out, the first thing you're going to ask yourself is, what can I do to change that? And this is exactly what our project is meant to do. Is meant to telling you what you need to change in order to achieve your desired output. And so going back a little bit, we want to explain what is counterfactual and what are we going to be talking about today. And so a counterfactual is an argument that consider what could have been the result if something different would have happened. So in my case, if my BMI will decrease from 35.6 to 20.1, then I will not have a stroke. And this is exactly what we meant to do, is basically, why did the model predict it? This is what we're trying to understand. Why did the model predict that in 5 years I will have a stroke? And what can I do to change that? And this is exactly what we're going to talk about today. And so our goal is to support large data set. You see, there's many packages and state-of-the-art approaches that can do that. But the problem is it's very, very slow. And thinking of companies like INTUIT or other companies with many, many users, generating counterfactual for each one of them will take a lot of time and resources. And so we wanted to do something that will support large data set, but still be very, very good. And we also want to beat other generators on the market, but this is just because we're very competitive. And so when we think of counterfactual and what is important, we need to take in consideration a few things. And many of these things are relevant, but most importantly, we need something informative. We need something that is feasible and realistic. I can't tell someone that if now you have 4 kids and if tomorrow morning you'll have only 2 kids, then you'll get the loan, right? It doesn't make any sense. I can't tell a man to get pregnant and his situation will be much better. And so I need to think of something really, really good. And I need to also make it diversity. Because if your only options to not have a stroke is to lose, 70% of your weight, then maybe that wouldn't be much realistic. And so taking all of this in consideration, we think of our entire algorithm. And though we don't have enough time to really talk about everything that's on this board, we do took in consideration in our algorithm weighted KNN and PCA and binary search and probability and many, many of the algorithms here to make the package fast and very, very good. And so let's take an example. This is a data set of people who are asking for a loan. And what we want to do is the users can come and say, okay, at this situation, I'm asking for a loan for my bank. And the bank told me that I can get that loan. And so what can I do in order to change that outcome? And so I can come as a user and saying, I don't want to change all my life now to get that loan, but change only my income or my credit score and see what can I do. And so taking in consideration only the credit score and annual income, we created an algorithm that can take your data set you see this black dot, and trying to move it to the other side of the decision boundary, trying to understand what can we change in order to move to the other side of the decision boundary. And this is exactly what we did, using binary search and weighted KNN and PCA to lower the dimensionality of our data. And using this algorithm, using binary search, which is very, very, very fast and simple algorithm, we could achieve our desired output. We could have went to the other side of the decision boundary, yet keep it minimal distance and make it feasible and realistic. And so moving on, this is the data that we got. And now for the results. And I know that we said we want to beat other generator on the market, but that wasn't really our main goal. But okay, never mind. But really, the one thing that we really want to test is our package really good, or we just created another GitHub repository that will stay in GitHub, or we did something good. And comparing to DICE, DICE is the state-of-the-art approach that now many uses in many algorithm. And the problem is that DICE is very, very slow. And since it's the state-of-the-art approach, we know that we're going to compare ourselves to DICE. And now we did a test on 1,000 instance generating counterfactuals. Think of it as 1,000 customers. DICE took about 7 minutes to generate these counterfactuals. Now, double it in millions when we're talking about big companies, that's a lot of time and resources. We took only 47 seconds. And I know that now you're thinking, okay, but your result must be worse. And so moving on to the results, there's many ways to really evaluate model explainability, counterfactual generator. But we did the simple one because we only have 4 months. And we compare by distance. What is the minimal distance that I need to go through in order to move to the other side of the decision boundary, in order to not have that stroke? And so DICE was about 1 million distance, and we were only about 3,000 distance, which is about 300% better. And now I know you're saying, okay, but this is numbers. Like you can really buy me with them. And so let's see some examples. And taking into consideration, for example, this example, which is about someone with, this is his feature, the current loan amount, the term, the credit score, and the annual income. Our generator, our package state, if you increase your credit score with only 2% and your income in 45%, you'll receive the loan. DICE suggested increasing your income in 900%, which is nice, but not that possible. And many other examples where DICE really, if anyone familiar with the credit score issue, the higher the better. So lowering my credit score would be like lowering my income. Doesn't make any sense. And so we can see that our generator is much more reasonable and makes sense. And so we can also see here, DICE suggested increasing the income in like really big number, while our generator really was realistic and achievable, which is, this is what we wanted to create. And so, Vera will continue. Thank you.
Yes, and a bit more about what we have done. So you see that accuracy operation is very nice and high, but distance isn't everything. So we also improved the model, and we added a mode in which we accounted for feasibility, as we have mentioned. Yeah, I will, what's feasibility? I will, one moment, I will show you the picture. So what could happen? We could fall into the gap when into the area when there are no observations of our data set. So for example, pregnant man or something like that. Yeah. So we can get, as a counterfactual, we can get a combination of features which really can be combined. As a pregnant, as I have mentioned. So for that, we improved the model and we added the feasibility mode, and it's a novelty thing. So we now only face package, which accounts for feasibility, but unfortunately it doesn't work very fast because it's based on graph Dijkstra algorithm. But in opposite, we have developed a new modification of well-celled algorithm and particle swarm optimization, and it can be parallelized as well, and it works very fast. And now, when you are thrilled enough, I hope, I will show you how you could use this package. So, the installation. You can install it via pip, and it is very user-friendly because we really tried to give a lot of freedom for the user. So, for example, you can define the configuration of the model, features to change. That means that you can choose any features that may be changed. For example, credit score or income or purpose for credit. But at the same time, you can also restrict the number of features that can be changed. For example, only 2, and you can change only 2 free. Then you should also input an instance and load a data set into the model. And you should also choose the model, the mode of the model. And then this is the configuration, features to change, a number of counterfactuals, because in the future version we will also deploy the multiple number of counterfactuals. Then you upload the model, and I should emphasize that there is only one thing that we want from the model, only predict method. It's model agnostic, so we don't know what the model is behind. And then the configuration and the target class. And also the user has the possibility to define the feature range. For example, he could say that I don't want my income. I want from my income that it should vary from -10% to 10%, not more. But of course, there is a risk in this time that there will be no counterfactual. So in that case, the user should relax the restrictions. Okay. So that's the model gives us the counterfactuals very fast. And you see that it can be parallelized. And so it gives us the result in this way, the table and the picture, the graph. And it's very easy to compare visually or with the table. So, yeah. So accomplishment, support of large data sets, fast generation, very fast, and beat other generations, and even apply the mode which no packages don't have on the market. We handle categorical features in a smart way. The medial article is to be proceeded. And before we proceed to the question, I want also to thank our mentors. We want to thank Yair Horesh for the brilliant idea of counterfactual generation. And also we want to thank Dina Bavli, the mention please, she's the best Y data mentor. She has accuracy 100%.